So I think we can continue with a little part of the chapter 2, okay, which is all about the force vector. Right. So the objective for this chapter, okay, the first objective is at the end of this lesson, you should be able to, right? So you should be able to let me minimize. Right. So you should be able to show how to add forces. So in this chapter, you will know how you want to add forces and resolve them into components using parallelogram, triangle, and Cartesian method. So we have three methods. We have parallelogram, triangle, and Cartesian. So you will learn all of those methods, okay? Parallelogram, triangle, and Cartesian. Right. Next, you should be able to express force and position, determine their magnitude and direction, okay, in the Cartesian vector. All right, the third objective is you should be able to determine the angle between two vectors and the projection of one vector into another by using the dot product operation. So I think towards the end of this chapter, you will learn about the dot product in order for you to find the angle between two vectors. All right. So for this chapter, we only have three objectives. All right. So let us proceed with the first part of the chapter. Right. So the first part of the chapter is all about the vector operation. So what is actually vector operation? So you can see here, this is actually a bridge which is stabilized by cables. Okay. So those cable, which it will give some forces to the point of connections. Okay. So how this kind of bridge can be stabilized by the cable? So we will learn how to express these forces as Cartesian vectors and then determine the resultant force. Okay, so actually this cable has stabilized the what we call the bridge tower by exerting what do we call it's not a stable, it's like a balance force between the two, so that it will be standing still. Okay, so the bridge will not be collapsed. Okay, it's just by using the cable. Right. So this is the next example. See, it is similar to the one which the bridge example. So this structure is stabilized by also using the three cables. So this tower is stabilized by three cables. Okay. So how to make sure the tower is in place? So do you know how?
All the forces added up has to equal to 0.
Yeah, that's true. Okay, so the next part of this chapter, we will learn on how to make sure that this tower can stay in place. Right. So before that, we need to know what are the fundamental of the vector operation. Okay, so in the vector operation, we have scalars and we have vectors. Okay. Okay, for scalars, for the example of scalars, we have the mass or the volume. Okay, the example of the vectors, we have the force or we have the velocity. Okay, for scalars, it only has a magnitude. For example, mass only have 10 kilo, 5 kilo, or negative 5 kilos. Okay, so it only has a magnitude. But for vectors, which is the force, it has magnitude and direction. Okay, so if you exert a force, you must know where the object has been going. So that is the direction of the force. All right. So for scalars, the addition rule is a simple arithmetic. Okay, it's just 1 plus 1, 2 plus 2. You don't have to use any other law. Okay, but for the vector, we have parallelogram law, we have rectangular, and we have Cartesian addition rule, or any other rules. All right. Okay, for scalars, you have no special notation. So you just can write as A, B, and C. But for vectors, you need to put the font in bold, or you need to put a line up, what do you call the line above the parameter name. Okay, and also you can put an arrow. Okay, so it is your option. All right, but you need to do this. You need to put a special notation so that we will be able to verify whether it is scalar or it is a vector. Right. So next is the multiplication and division of a vector by a scalar. So you see here, this is A, which is a vector A, which has been multiplied by a scalar number 1. 1 multiplied by A. And this is vector A, which has been multiplied by a scalar number 2. So it means that the arrow become longer because more value is exerted. Okay, and this is a vector which has been multiplied by a scalar of -1. So when it is negative, the direction of the vector will change. Right, so it will be on the opposite direction. Okay, so similar to the last example, so if we divide this vector A by 2, okay, A divided by 2, actually this one is A divided by -2, okay, so it become negative 0.5A. Right, let me change the, okay. Right, so this is the example is actually A divided by -2, so that it will become negative 0.5A, right? So you must aware with this. This is an error in the slide, right? Okay, so next is vector operation, magnitude and direction. So you see here, we have two vectors, vector A and vector B. So I wanted to ask you, is vector A equals to vector B? Guys, does vector A equals to vector B? Do you know? Can you hear me?
It's no, sir.
It's no. Right, it is correct. Okay, so vector A and vector B have same direction, but it has different magnitude because vector A is longer than vector B. So vector A is not equals to vector B. How about this? Is vector A equals to vector B?
No.
Yes.
No.
Why?
It's not parallel.
Different direction.
Yes, correct. So vector A and vector B, it has the same magnitude, but it has different direction. Therefore, it is not equal. But what about this?
It's
Yes.
equal, sir.
Same.
Well, all right.
Both are equal.
Okay, that's correct. Okay, so vector A and vector B have the same direction and magnitude. Therefore, it is equal. Okay, next is addition. Okay, so to perform vector addition, vector quantities follow the parallelogram law of addition. Okay. All right, so let's say you have two vectors, vector A and vector B, and you wanted to add it together. So how you should do it? So first, you must connect, of course, you need to connect each vector altogether. And the next one is you must draw an imaginary line which is parallel to vector A and imaginary line parallel to vector B. Okay. And then after that, you will get an intersection point at point P. Okay. So after that, you need to draw one additional error, which is called the R, which is the resultant force. So resultant force is like the summation, it's like the hasil of the addition or the multiplication or the division or the subtraction of the force, right? So first you need to draw the perpendicular line of A and perpendicular line of B, and then you get the intersection point, and then you draw another arrow which is start from the origin and goes towards the intersection point, and you name it as R, which is the resultant force. Okay. Right. So next is we have a special case. Okay. So previously you see here, each force or each vector is connected. We call it, this one is tail, this one is head. Okay. So it is connected tail to tail. Okay. But if the vector is connected from, this one is head to tail, you need to use a triangle rule. Okay. So if the vector is connected from head to tail, vector A, the head of vector A is connected to the tail of vector B, you need to use a triangle rule in order for you to do the addition case of vector operation. Okay? So in certain cases, triangle rule is used to perform vector addition. Right? So it is similar to the other, you know, it doesn't matter lah what is the orientation of the vector. As long as the head of one vector touch the tail of another vector, you need to use the triangle rule. Right? Okay, next is subtraction. Okay, so for subtraction, the parallelogram law is similar. Okay, you just need to draw the perpendicular line, parallel lah. Okay, you need to draw the parallel line of the vector, each vector, and the intersection, you draw the resultant force. Okay, so this is the parallelogram law of vector subtraction. Okay, but you must remember that in order for you to draw the parallel line, you need to follow the direction of the arrow. Okay, so when you draw the imaginary line here, shows in the blue line, it will become a parallelogram. So this is why it calls the parallelogram law. Okay, so for triangle construction, it is similar. If the head of one vector touch the tail of another vector, you need to use the triangle law. Okay, but you need to aware with the direction. Okay, you must know and you must be verify yourself what is the correct direction of your resultant force. Okay, so here resultant force R equals to A minus B, or it is actually A plus minus B. Okay, A plus minus B is the direction of vector B is in the opposite direction of vector A. Okay. Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we will continue our lesson on engineering mechanics chapter 2, which is all related to the force vector. But before we proceed with the today's lesson, so let us recap what we have learned last week. So first, last week you have learned about scalars and vectors and the differences between scalars and vectors. Next, you have been taught about multiplication and division of a vector by a scalar. Alright? So your arrow will represent your magnitude and direction of your scalar. Right. So next you are learning about the vector operation, magnitude and directions. Alright? So as you can see here, so if vector A and vector B, has the same direction but it has different magnitude, so it is not equal. So if A and B, vector A and vector B has the same magnitude but different direction, it is not similar. But if both vector A and vector B has the same magnitude and the same direction, it means that vector A equals to vector B. Alright, next you have learned about addition. So in order for you to perform the vector addition, you need to draw the parallel lines between vector A and also parallel line between vector B. Okay, and then the intersection line is the resultant force that you will find. Okay, so next is the special case. So if your force vectors, if you wanted to add or substitute your force vectors, okay, if each force vector, if the head of the first force vectors touch with the tails of the second force vectors, it means that you can use triangle rule to find the resultant force. Okay. Alright. So this case is similar with subtraction. So you can see here for parallelogram law, okay, if the tail of the first force, which is the force A, touch with the tail of the second force, which is the force B, the resultant force will be produced by using parallelogram law. Okay, but if the head of the first force vectors touch the tail of the second force vectors, it means that you can use the triangle law. Alright, so this is what you have learned last week. So this week you will learn about how to find a resultant force. Alright, so let's say you have the force F1 and the force F2. Okay, so as you can see here, force F1 and force F2, the tails touch each other. So it means that you need to use a parallelogram law to find the resultant force. All right. So to find the parallelogram law, so you need to construct like a parallel line between for F1 and parallel line for F2. Okay, so the parallel line must start at the head of the force. Okay, so you see here, this is the first one. The head it started at the head of the first one. You need to construct the parallel line of the force F2, similar to the head of F2. You need to create a parallel line of F1, which starts from the head of vector F2. All right, and the intersection line here, you need to construct like a additional vector here, which is the resultant force. So resultant force is actually the cumulative force that is the output, which is from your addition or your subtraction or any other vector operation. All right. Okay, so in order for you to find the resultant force, you can use the law of sines or law of cosines to the triangle to find the magnitude and direction of the resultant force. All right. So after you find the parallelogram shape of your force, okay, you can use the you can convert the parallelogram into the triangle shape, because this line, okay, is parallel to F2. So it means that you can put F2 here. All right. So when you put F2 here, it will become a triangle. F1, F2, and the resultant force. Okay, so from here you can find your resultant force by using law of sines or law of cosines. Right, so this is the example of the vector addition of forces finding a component of a force. All right, so let's say you have a resultant force F here. All right, and your resultant force F move along the axis of V and U. Okay, so in order for you to construct the forces V and forces U, okay, you must start with the head of the resultant force. Okay, the head of resultant force, and then you draw the parallel line of V, which is indicated here, and then parallel line of U, which is indicated here. Okay, and then you can draw the force which starts from the origin here until the intersection here, intersection of the parallelogram that you have been drawn previously. Okay, similar to here for FU, force U. All right, and then from this parallelogram shape, you can convert it into a triangle by replacing FB here into here, because this is a parallel line. So it means that the force here is similar to the force here. All right, so from this triangle you can apply law of sines to find the magnitude of the resultant force F. All right, okay, so this is the resultant force F, and this is law of the triangle's law of cosine or law of sine. Okay, so from here you can substitute the value of F, FV, and FU, okay, in order for you to find the resultant force. For example, if you wanted to find C equals to the square root of A squared plus B squared minus 2AB cos C. Alright, and the sine law, A over sine A equals to B over sine B equals to C over sine C. So from these equations or from this formulation, you can find the resultant force and also the direction. So the direction here is representing the orientation or the angle that you wanted to find. All right. Okay. Next situation is the addition of several forces. So what are the resultant force if you have multiple forces? Okay. So in this situation, you have three forces. You have force 1, you have force 2, and you have force 3. So what you should do is you should solve one by one. So it means that you must do the two addition of forces first. Okay. For example, F1 plus F2. And then this is the resultant force of F1 plus F2. And then F1 plus F2, you will be adding with F3. Okay. And then you will find the resultant force of FR. Okay, so in order for you to find the resultant force, you need to add the two component of force first, and then the what you call the product of the addition you will be adding to the next force. Okay, all right. So if you have multiple forces, what you should do is you should add each in each operation you need to add only two forces. All right, and the product of the two forces you will be add in the next step. Okay, so each part of the calculation must only consist of two element of forces. All right. Okay. So next is step-by-step example. So this question asks you to determine the magnitude and direction of resultant of the forces shown. So in order for you to find the resultant forces, what you should do? So based on our previous lesson, this is actually tails meet with tails. So what you should do is you should use the parallelogram law. Okay? So construct a parallelogram by drawing two lines. Each line starts at the tip of one vector and is parallel to the other vector. So the first things that you need to do is you need to draw a parallel line in order for you to construct a parallelogram. Okay, parallel and parallelogram. So those things are, related somehow, the name. All right. Okay. So this is the force that that has been given. Okay. So you draw the parallel line which starts from the tip or the head of the first force. You draw the parallel line of this force, 200 Newton force, and then the other you need to draw from the tip, and then you draw the parallel line here, which is parallel to this line. All right. Okay. So from this line, okay, you will have it has been given here the angle of 30 degree. Okay, so the angle of 30 degree is the angle between the 150 Newton force here and also 200 Newton force here. So 30 degree here will also similar to here 30 degree because the line is parallel. So the angle must be similar. Alright, so the second step is, since opposite sides of a parallelogram are equal in length, so the length of each line represent the magnitude of the vector opposite. Okay, so as you can see here, the length here 200 Newton, it is equal to here, this is also 200 Newton because the length and also the angle of each parallel line is similar. Okay, so when you are drawing the parallelogram shape, so the parallel line between each segment is similar in magnitude. All right, so this is 200 Newton and this is also 200 Newton. Similar to here, this is 150 Newton and this is also 150 Newton here. All right, so the next step is, so the resultant R, which is the resultant force, is drawn from the tails of the vectors to the opposite vertex of the parallelogram. So based on our previous lesson, if we are using the parallelogram law, okay, after we are drawing the parallel lines, okay, the part where the line, what do we call the line intersects, which is here, is the resultant force. Okay, so it must starts with the where the tails are, okay, and you must connect it to the intersection line of your parallelogram, so the parallel line that you have drawn before. Okay, so this is the resultant force. All right, so this is not the resultant force because it is not drawn from the intersection of the tails. Okay, so when you see here, this line is not the resultant force because it is not drawn from the tails intersection here. Okay, so it must drawn from the tails here to the intersection line where you are newly drawn your parallelogram. Okay, so this is actually your resultant force. Okay, which is the intersection line. All right, so from this parallelogram law, okay, as you can see, you can convert it into triangle. All right, by using this parallel line here that you have drawn, 150 Newton, and this is 200 Newton, and this is the resultant force, R. And you have the degree here, 30 degree, that has been given. Right? From this parallelogram, you can convert it into a rectangle. I'm sorry, into a triangle. All right? So, in order for you to find the resultant force R, you can use the sine or cosine rule, which is, here you are already given 30 degree here. So you can use the cosine law. All right? Okay. So for this tutorial, we will do some questions, okay, in our next class, okay, in the next class. All right, so you will be given some of the example and we will do our tutorial session together. All right, so next is the addition of a system of coplanar forces, scalar notation. So previous lesson, the previous lesson, we are calculating the resultant force without any plane, okay? So if it has a plane, it must be specified. But this time, the plane is it's like a fixed plane. Okay, so it means that you can represent your forces in two types. Okay, all right. So rectangular components is where force is resolved into two components along x and y axis. So in this section, each force will be divided into two axes, x axis and y axis. Okay, but previously it doesn't mention any axis, so you are finding the resultant force in general, but this time you have some axis. All right, so if the force have an axis, so you can represent using two methods, using scalar or using Cartesian vectors. All right, so this is the example of using a scalar notation. All right, so you can see here you can see you have the resultant force F here, and then you have the y-axis and x-axis. Okay, therefore you have the force of y, which is directly connected to the y-axis, and you have force x, which is directly connected to the x-axis. Okay, so by using the parallelogram law, the resultant force F can be defined as Fx here, okay, plus Fy prime, because this is Fy. And if we wanted to create a triangle, we must use this one, Fy prime. So because Fy prime is parallel to Fy, so the magnitude is similar. Okay, so you can use the parallelogram law here. Right. So in order for you to find the Fx, which is the force with respect to x-axis, you need, the formula is F, which is the resultant force, cos theta. So this is the theta here. All right, and the forces of y, which is the force with respect to y-axis, okay, it is equals to the resultant force F sine theta here. Okay, all right, or you can use a small slope triangle. Okay, so if you are using the small slope triangle, Fx, okay, which is the force with respect to x-axis, equals to B over C multiplied by the resultant force. Okay, or y, or the Fy, the force of with respect to the y-axis equals to negative A over C multiplied by F, the resultant force. All right, so this is the way if you wanted to represent your force by using scalar vector. All right, but what about Cartesian vector? So if you wanted to represent your addition of a system of coplanar forces by using Cartesian, so x and y component represented in unit vector I and j. So in Cartesian vector, you will have a component of I, which is represent the x-axis, and j, which is represent your y-axis. Right? So this is the example of the addition of a system by using coplanar force resultants. Okay, so you can see here you have F1y here and F1x here, and this is F1. Okay, your resultant force F1. So F1 equals to F1x. Okay, for x we have I, plus f1y. For y, you have j. Okay, so each component of x must have the letter I, and each component of the force y with respect to the y-axis must have the component of j. Okay, so later on we will try some of the example in order for you to improve your understanding of representing your system of forces by using scalar or Cartesian. All right, Cartesian form. Right, so for Cartesian form, okay, and also the for what do we call for the scalar vector notation, okay, if you wanted to find the resultant force with the condition that you already have the total force of with respect to x-axis and total force of y-axis, okay, this is the resultant force equals to the square root of the total force of with respect to x-axis plus the square of the total force of with respect to y-axis. Okay, so you can find the resultant force by using this formula. And if you wanted to find the theta, which is the direction, you can use the tan inverse the total force of y over the total force of x. Okay, this is the what do you call the magnitude direction, the magnitude notation. It means that it is always positive. Okay, can you see the questions?
Yes.
Yes,
Okay,
sir.
right, so this is the question that we have. Okay, so first you have a diagram here, right? And the questions are described as if theta equals to 30. Let me. Okay. So if theta equals to 30, so theta is here, okay, and T equals to 6 kilonewton, okay. So T here equals to 6 kilonewton. So T equals to 6 kilonewton, okay. So the questions ask you to determine the magnitude of the resultant force acting on the eye bolt. So this is the eye bolt, okay, and its direction measured clockwise from the positive x-axis. So first, what you should do if you get this kind of questions? Guys, what you should do if you get this kind of questions?
Draw the free body diagram.
Yeah. So first, what you should do is you should draw the free body diagram. Okay. So first you need to draw the y, the x. Okay. Okay. So this is y. So this is x. Okay. You have a total of two forces here. You have the force of E here, and you also have the forces that you already given here. This is 6 kilonewton equals to 6 kilonewton, and this is 8 kilonewton. Okay, so in order for you to solve this problem and where you need to find the resultant force, you should draw the parallelogram. Okay, so in order for you to draw the parallelogram, what you should do is you should draw the parallel line. So this is the parallel line. Here you can draw the parallel line in order for you to find the angle. So you need an angle in order for you to solve the problem. Okay, so this is the parallel line for the second force. Okay, right. So this is the parallelogram, right? So the intersection line that you have is here. Okay, so your resultant force should be close to here. Okay, all right. Okay, so this is Fr, which is the resultant force. Okay, and in the question, it is also given the theta equals to 30 degree. So you need to put theta equals to, this is theta 30 degree. So this is 30 degree, and this is 8 kilonewton, and this is 6 kilonewton. Okay, so from this, what do you call the free body diagram? Okay, you can already calculate the angle. Okay, so it has been given here. The angle from here to here is 45 degree. Okay, so this is 45 degree, and this is 30 degree. Okay, so for the what do you call the parallelogram? Okay, the other degree that you have is here. You have the x-axis here, and you have the y-axis here. So the angle between y and x-axis here equals to 90 degree. Okay, so it means that the angle from here to here is 60 degree. Okay, right. So next, okay, in parallelogram, you have this shape, right? This 1, 2, 3, and 4. Okay, so the total angle from this area to angle of this area equals to 180 degree. Okay, so because this angle is 60, so 60 plus 45 degree equals to 105. Okay, so what is the angle of here? Can you tell me what is the angle of here? Total here plus this one is 180. So this one is already 105. So what is the angle here?
75, sir.
Yes, so this is 75 degree. All right. Okay. So next, what we should do is we should convert this parallelogram into triangle. Okay, in order for us to solve the problem. Right. So next is to convert it into triangle. So we have the resultant force here, the angle here. We have some angles here. Okay. So you have this is your resultant force, right? So this is the value of this force is 8 kilonewton. Okay, so this is 8 kilonewton, and this one, okay, this line is actually similar to this one because it is parallel line. Okay, so it means that this line becomes 6 kilonewton. Okay, and then you already got the angle. So the angle that you got from the previous parallelogram here, you already got this angle is 75 degree. So this is 75 degree angle, right? Okay. So right now you can already find your resultant force, okay, by using the cosine or the sine law. Okay. So for cosine law, okay, it is, for example, C equals to the square root of A square plus B square minus 2AB cos C. Right? So this is your cosine law. Right? So right now, we wanted to find the resultant force. So you can already find it by using cosine law. So let's say FR equals to C. So this is C, this is A, this is C, this is A, and this is B. Right? So you can do as follows. Okay? FR resultant force equals to the square root of A square, which is 8 kilonewton, 8 kilo square, plus 6 kilo square minus 2, 8 kilo, 6 kilo cos. So the theta C is here. Okay. If you wanted to identify where is actually the theta, it is actually the opposite of the segment. Okay. So this is segment C. The theta of C is here. Okay. So this is segment B. So the angle of B is here. So this is angle B, right? So this is segment A. So the angle of A is here. So it is opposite of the segment, right? So this is angle Right. So right now, cos we already find last time. Okay, here 75 degree. So we just put 75. Right. So if you calculate your this value will become 8,669.10 Newton. Okay, and as we already learned, if the value is quite a lot, okay, so we need to put some prefixes. Okay, so it will become 8.67 kilo Newton. So this is the magnitude of the resultant force for these questions, right? Okay, so these questions ask you to find the magnitude and also the direction. So what are the guidelines for the directions? So the direction that it mentioned is it must measure clockwise. Okay, so you must measure clockwise from the positive x-axis. Okay, right. So here what we can do is this is clockwise. Okay, this is the positive x-axis. If it is mentioned that negative x-axis, it is from here. This is negative x, and this is negative y. Okay, so what this question asks you is they wanted you to find the angle of here. Okay, this is the positive x-axis and this is the resultant force, and the direction is here. Okay, so you must find the, for example, alpha here. So what is the value of alpha here? Right? So to find the value of alpha, you can use the sine law. Okay, sine law. Okay, you can see here. Right, so for sine law, it says that A over sine A equals to B over sine B equals to C over sine C. So from here, you can already find your angle because you already got your angle previously. Okay, so what we can do here is that you already got your resultant force here. Fr equals to 8.67K. Okay, and then you wanted to find the angle of alpha. Okay, and you already got the angle here, right? So you can draw this rectangle. This is written here. Okay, so this is 75. Let me in. Right. So this is 45. This actually this is 75. This is here. Let me draw. Okay, so this is x-axis. Okay, right. So the angle here is 45, but we don't know the angle here, alpha. Okay, all right. So by using this law, right, it will become A is equals to we take this one. C we already find. C previously we have 8.67 kilo over sine C. Sine C, the angle of C is 75. Okay, over sine 75 equals to, so we wanted to find the total angle of B. Okay, so we have the value of B is 8 kilonewton, 8 kilo over sine B. Okay, so B here is actually B equals to 45 plus alpha. Okay, so
Hello. Sir,
hello.
sir, bukan betul 6 kilonewton ke?
6
Kan? B tu 6.
Bis je.
Bukan 8 ke ni? 8 ni?
Tapi tu segmen A kan so yang 8 kilonewton.
Yang
Segmen B is 6 kilonewton kan?
Betul. So this is 6.
Alright, sir.
Alright, okay, sorry. So this is 6K over sine B. Okay, 6K over sine B equals to B represented 45 degree plus alpha. Okay, so when you solve this equation, you will get B equals to 63.03 degree. Okay, which represent 45 plus alpha. Okay, so the Fresnel value of alpha that you will get is okay. Oh, sorry. I have a little mistake here. So this is not the answer. Okay. So you can calculate by yourself. Okay. So let me calculate first. Okay. Sorry. So let me write again. 8.67 K over sine 75 K equals to 6K over sine B. So what is the value of B here?
$45 plus alpha, right, sir?
45 plus, right now you solve for B first by using this equation. From this equation, you solve B. And you get the value of B.
Is it 41.95 degrees, sir?
Yes, so B equals to 41.95 degree. Okay, so 41.95 degree equals to 45 plus alpha. So alpha will equals to 41.95 minus 45 equals to negative 3.05. All right. So because for these questions, the direction is actually negative, but I think we should put the direction to become positive degree. But later on, I will verify to you. Okay. So either it is positive or either it is negative. So I think it will become positive 3.05 degree. Okay, because the magnitude and direction for the force vectors is actually positive. Okay, it doesn't have any polarity here. It only have the direction. Okay, so it become positive here. All right, can you understand this example?
Yes, sir.
All right. So next, let's take a look at the next example. Okay, so in the next example, okay, so the question mentioned to you that if the tension of the cable is 400 Newton, determine the magnitude and direction of the resultant force acting on the pulley. So this angle is the same angle theta from line AB on the tailboard block, right? So this question, it is given that this is a cable and this we have a tension here. Okay, so the tension of the cable is 400 Newton, right? Each cable has the force of 400 Newton. So the questions ask you to determine the magnitude and direction of the resultant force acting on the pulley. So they wanted you to find what is the resultant force, the magnitude and also the direction. So this angle is the same angle theta from line AB from the tailboard block. Okay. All right. So it is actually given that the angle from the the cable to the angle of the axis y here. Okay, and also the magnitude and the direction, we need to find it. All right, so what we should do is we should first, as usual, we need to draw the free body diagram. Okay, so let us draw first. Right here, one here. Okay, 400 Newton, and this is also 400 Newton. Okay, so as usual, what you should do is you should draw your parallelogram, right? Okay, you should draw your parallelogram. And then this is your, right. Okay, so from your parallelogram, you can get your resultant force. So this is your resultant force, Fr. Okay, and from the parallelogram, it is already mentioned that it is already given that the angle, the first angle here, okay, it is given that it is equals to 30 degree. 30 degree here, right? So what we can conclude here is that if we draw another diagonal line here, okay, the diagonal line here is also equals to 30 degree. Okay, right? Because this line and this line is similar in angle, and this is the axis angle, axis line. So we draw another axis line, you will get 30 degree here. So because of this diagonal line, okay, this is the right angle. So this angle will become 60 degree. Okay, right? So because this is 60 degree, this is also become another angle. Okay, so okay, right. So right now we can solve the problem of your resultant force. All right. So from here you can convert it into the triangle. Okay. Right. Okay. So this is 60 degree. Okay, and then this is your FR. Okay, and this is 400 Newton, and this is also 400 Newton, right? And by using the cosine rules, okay, you can get FR to 400 square plus 400 square minus 2, 400 multiplied by 400 cos 60, and later on you will get also 400 Newton. So your resultant force is also equals to 400 Newton. So this question is quite direct because the forces of two is similar. So the resultant force is also will become similar usually. Okay, but it also depends on some situation. Okay, so as usual, if you wanted to find the direction of the resultant force, so you can just find by using the sine rule. So you have 400 FR you already have 400 over 60. So this is actually your magnitude. Sorry, your direction. The direction angle is here. Okay, one is here. So you have your alpha here. So 400. Sorry, this is 400 over 60 equals to 400 sine 60 over sine alpha. So when you solve for alpha, you can also get alpha equals to 60 degree. So this example is actually similar to the previous example, right? But you must, understand the questions directly. Okay, so if you misunderstand the questions, so you will not get the correct answer, right? So this is actually simpler from the previous example. So can you understand this example? guys?
Yes.
Yes, sir.
Yes.
Okay. So we
Yeah.
go to the next example. Right. So next example will be related to the scalar and Cartesian force. So which is the next session of our lesson, right? So these questions, it asks you to determine the magnitude of the resultant force acting on the pin and its direction measured clockwise from the positive x-axis. All right. So when you see any questions, if if you have multiple forces, it is actually easier if you solve it by using scalar vectors instead of you are solving by using parallelogram law. You need to do two parallelogram. Instead of that, you can solve by using the scalar vector notation. If the question didn't ask you to convert it into Cartesian, okay? But if the question asks you to convert into Cartesian form, you need to convert it into Cartesian. But if it doesn't mention, you can just solve it by using the scalar, right? So you can see here, all right? Here we already have, actually this is 15. 15 degree here, okay? So this is the figure that you have, okay? So as usual, if we wanted to draw the triangle. Okay, so for the scalar or for the Cartesian, you must remember back your what you call your high school or your secondary school's rules of triangle. Okay, so if we have a triangle here, right? Okay, we have a theta here. This is the adjacent, we call it A. Okay, and this is the opposite, we call it O. And this is the hypotenuse, we call it H. All right. So can you remember what is cos theta equals? Cos theta equals to what? Can you remember?
Adjacent over hypotenuse.
Hypotenuse.
Yes, A over H. Okay, and then you have sine. Tan theta equals to?
Opposite over
O over
hypotenuse.
H.
Okay, O over H. If tan?
Opposite over adjacent.
For adjacent.
Oh.
O over A.
Okay, right. So for this lesson, you need to go back to your secondary school lesson and you need to aware of this, right? Because if you wanted to convert it into scalar or Cartesian vector, you need to what we call the reconstruct your forces into x and y axis, right? Okay. So if you want to, we go one by one, okay? So first we go force one first, all right? Force one, we have F1 here. Okay. Okay. So we have here 45 degree. F1, 45 degree. Okay. So this is y-axis and this is x-axis. Okay. So this is F1y, F1x. Okay. So for force 1, okay, we call it F1 x equals to F1x. So we have the force here. F1 equals to 30 Newton. Okay. So F1x equals to 30. Okay, because F1x is here, the adjacent. Okay, you can use the the cos one. Okay, hypotenuse multiplied by cos theta equals to adjacent. Adjacent here equals to F1x, right? So F1x equals to 30 cos 45. So when you calculate, you will get like a 21.21 Newton, if I'm not mistaken, right? So next you have F1y. So F1y here represent O, the opposite. So in order for you to find the opposite, you can use the sign one. Sin theta multiplied by H equals to opposite. Okay. So F1y equals to 30 sine 45. So you will get also 21.21 Newton. Okay, so if I'm wrong, you can correct me. All right. So next you will go to the F2. Okay. One. This is F2. Okay, F2. Okay, F2. Okay, F2 here. So this is F2. F2 equals to 40 Newton. Right? So the angle here is 15 degree. Okay? So this is 15 degree. So this is actually the F2y and this is F2x. Okay? So can you tell me how to find F2x? What is the value of F2x? This one. Guys? Can you hear me?
38.64.
38.64. So the equation is like this, berapa ni?
40 cos
40
15.
cos 15.
40 cos 50. So you will get 38.64, right? Newton. Okay, so for F2y, what about F2y?
10.35.
10.35. So 40
40
sine
sine
15.
15.
So 10.35 Newton. Okay. So next we need to do again for force 3. Okay. So if you already, you're already common with this thing, you don't have to draw one by one. Okay. But we draw one by one in order for us to avoid some mistakes. All right. Okay. So force 3. Here, you have here this force 3 equals to 25 Newton. They have a timer here. You have 15 degree. 15 degree here. Okay, so this is cos 3y. And this is cos 3x. So cos 3y equals to, sorry, for cos 3x first. Cos 3x equals to, what is cos 3x?
24.15.
Are you sure?
Not sure.
So here, cos 3x, it represents what? O, H, or A? F3x.
Oh,
Oh,
So what is the answer? 25?
25 sine 15 lah.
Yes, 25 sine 15 equals to 6.47 Newton. So for cos 3y, it is 25.
Cos 15 is
Yes, cos 15 is equal to 24.15 Newton. Okay, so this is why we draw the triangle of each cos element, because we wanted to avoid some mistakes. All right. Okay, so next the questions ask you to find the magnitude. So to find the magnitude, you can just simply add, first you need to add all of the element of x forces. Okay, F1x plus F2x plus F3x. Okay, so first you must find, okay, so Frx. So force resultant x equals to F1x force 1x plus force 2x plus force 3x. Okay, so force resultant y equals to F1y plus F2y plus F3y. Okay, so if you try to add it together, you will get the value of 66.32. Okay, and for the second one is you will get the value of C 21.21. Right. So for this one, you need to so this one you will get the value of 13.29, negative 13.29 Newton. Okay, so for this one. So if you get the, you see here, for this one. Okay, so can you explain to me what is the magnitude for the force force 1y for this one? Is it positive or is it negative? This is force 1.
Positive, sir.
What about x?
Positive.
Yes, it's true. So for the second one, F2x. F2x positive, negative.
Positive, sir.
Negative.
Positive.
F2y?
Negative.
Yeah, so you put negative here. Okay, this one, F2x, F3x,
Positive.
F3y,
Negative.
Negative.
here. So when you add it together, you will get this answer. Okay. So finally, if you wanted to find the magnitude, okay, so Fr equals to the square root of Frx square plus Fry square. Okay, so this is your final answer. So you will get, for example, 67.6 Newton. So when you calculate, you will get this answer. Right? So next, we wanted to find the angle. Okay, the angle of your resultant force. Okay? All right, so for this one, you cannot draw your resultant force before getting your angle first. Okay? So this angle, okay, so they wanted to find the angle at the direction measured clockwise from the positive x-axis. So this is positive x-axis, clockwise is like this. Okay, so it means that your Fry, so according to the equation or according to the formula, theta equals to tan inverse Fry over Frx. So this is your direction. Okay. So when you solve this problem, Fry you already get here. You already got here. Frx you already got here. So you will get the answer of 11.3 degree. So this is your what do we call your resultant direction. Okay, so later on when you draw, okay, so you already get your, this is your magnitude 67.6 and this is your direction 11.3. Okay, so if the questions ask you, okay, so please draw where are the resultant force, right? So this angle is located clockwise from the positive x-axis. Okay, so this is x-axis, this is clockwise. Okay, so this is the direction, right? So you should draw somewhere here. Okay, and it should be longer lah. Okay, so this is somewhere here. It should be longer because of the magnitude. Okay, magnitude is higher. Okay, so this is FR. This 67.6, 67.6. It is longer before the 40 Newton. 40 Newton is shorter, right? And the angle here is 11.3 degree. Okay? Right, so can you understand this example? Or you want
Yes,
me
sir.
to
Can.
Yes.
can? Semua can Okay. So next, this is the last example for the one that we have learned. Okay. Okay, so this one. These questions ask you to express each of three forces acting on the bracket in Cartesian vector form. So this time, you need to do it in Cartesian. Okay. With respect to the x and y axis. So determine the magnitude and the direction theta of F1. So this is F1. So that resultant force is directed along the positive x prime axis and has a magnitude of 600 Newton. Okay. So for this example, okay, it is already given the value and the directions of your resultant force. Okay, so your resultant force says that it is directed through this is the x prime axis. So it is inside this axis, right? So this is your FR. Okay, so it is 600 Newton. R equal to 600 Newton. Okay, so this is your FR, right? And then this time, they wanted you to find the value of F1. What is the value of F1? And what are the angle of F1? Magnitude and also the direction of F1. So what you should do first is, they wanted you to express in Cartesian vector form. So you must remember and you must understand what are Cartesian form and how we wanted to convert into Cartesian form, right? So actually, it is actually similar to our previous example where we need to, draw the triangle and so on. But this time, we need to just put the element of I and element of J. So element of I, it is for x-axis force, and element of J is for the y-axis force, right? So we can do it like this. F1 is F1 equals to F1, okay, F1 cos theta. So this is theta. Okay, so you can draw the triangle as the previous example to to get on how we can get the cos theta and sin theta here. Okay, so F1 cos theta I is for the x-axis plus F1 sin theta, and then you have J here. J is for the y-axis. Okay, and for F2, because we already have here, F2 is already directed towards only the x-axis, so it doesn't have any y-axis element. Okay, so you can just write it as like this. F2 equals to 350 I Newton. So this is F2. Okay, so F3 equals to, so what is F3? What is the value of F3? This is F3.
100 J Newton, sir.
Yes. F3 is 100 J Newton. All right. So next, we wanted to find the magnitude first. All right, because we already know the resultant force. Okay. So in order for us to find the resultant force, okay, you can just use the previous formula, right? So FR, so this one. So next is resultant force equals to, okay, 600 cos 30i. So 600, so the direction is 30 degree. So 600 cos 30i plus 600 sine 30j. So this is the expression of the resultant force in Cartesian vector, right? Okay. So when you solve this cos and sine, you will get 519.6i plus 300j. Okay. All right. So right now we already get the resultant force for the x element and resultant force for the y element. Okay. So what we can do here is that you can, substitute and equate all of them together. Okay. So from here you have 519.6 I. You don't have to put I here, and then you equate with all the I elements here. Okay. So we have F1 cos theta plus 350i. 150 only. Okay, you can ignore the I here. All right. So after you move it all together, so you can get F1 cos theta equals to 169.6. Okay. So in order for you to solve these questions, you can equate the element of I and element of J separately. Okay. This is the equation of element of I. This is I. This is J. So for J, you can equate is 300 equals to F1 sine theta plus 100. Okay. So you can get F1 sine theta equals to 400. Okay, I'm sorry, 200. Oh, this is negative 100. Okay, sorry, this is negative 100 because it is in negative. It moved towards the negative part. Right. So it is similar as previous. Okay. So this is negative 100. I'm sorry. Okay. So you will get equals to 400. Right. Okay. So next you have the theta. Okay. So F1 sin theta equals to 400. Okay. So theta is actually, okay, let me make it. Okay. So when we goes to the previous example, theta, which is the direction of the resultant force, equals to inverse of tan of force resultant x, force resultant y over force resultant x. Okay, right? So this one theta of theta, we already have 30 here. Okay. Sorry, so theta here, theta equals to tan inverse 1, okay, in the bracket of FRY. FRY you can see here, okay, 100, this is for y, 400. Force resultant x is 169. 169.6. Okay, so theta equals to 6 to 7 degree. Okay, and next is you can get the final value, which is the magnitude, by substituting the theta here. Okay, so F1 equals to F1 cos theta. F1, you can substitute inside the value here. For example, okay, sorry. F1 cos 67 equals to 169.6. Okay, and you can get the value of F1 here. Okay, all right. So if you wanted to get the, sometimes you are wondering how we get theta equals to tan inverse this one, FRI, FRY, or FRX. So actually we got it from here. Okay, so when we are, we are dividing all together. So tan equals to sine over cos. Okay, so see here, tan is actually sine theta over cos theta. Okay, so if we divide it all together, here, okay, so this one F1 sine theta equals to 400 divided by F1 cos theta, which is equals to 169.6. So it becomes F1 sin theta over F1 cos theta equals to 400 over 169.6. So F1 we can cancel it together. Sin theta over cos theta equals to tan theta. So tan theta equals to 400 over 169.6. So this one equals to tan theta equals to 400 over 169.6. So this is how we get this equation. Okay, so from this equation, you get the value of theta, which is 67, and you can substitute here, or you can substitute here to find the value of F1. Right? So can you understand this example?
Yes.
All right. Okay. So right now we will take a 10 minutes break. Okay. And after this, we will continue. After this, we can continue with the continuation of the Cartesian vector. All right. So let's take a break first. Okay, guys, we continue with the next lesson. Okay, so the next lesson, can you see the slides?
Yes, sir.
All right, thank you.
Yes, sir.
Okay, thank you. Okay, all right. So next, we will learn about 3D space Cartesian vector. So previously, we already learned about 2D space Cartesian vector, which we only have two elements, x and y axis. X is represented by the I element, and y axis is represented by the j element. So that is 2D Cartesian vector. But this time, we will learn about 3D space Cartesian vector. So what are the differences? So for 3D space Cartesian vector, we will use our right-handed coordinate system. So I'm sure that you already learned in your physics, right? So if you remember your right-handed coordinate system, so your thumbs point to the direction of the positive x-axis. So finger are curled about the z-axis and directed from the positive x toward y-axis. So you have your right angle here. Okay. So your thumb will direct it towards the positive z-axis. Okay. And then you will have your y and x. Okay. So when you can also refer to this figure. Okay. So the z-axis move upwards. The positive x-axis move towards you. Okay. And the y-axis move towards your right. Okay. So your thumb points upwards, your jari telunjuk points towards you, and the other part of your, which is your middle finger, goes toward your right. So this is how the right-handed coordinate system works. All right. So this is one of the way that you can represent your 3D space. Okay. Cartesian vectors. Right. So for this 3D space, okay. So here we have A, which is the resultant force. Okay. So we have AZ here, AY here, and AX here. Okay, so A can be expressed as the combination of the X element, the Y element, and also the Z element. Okay. Right. Okay, so next, what is the Cartesian vector for 3D space? So first, you must consider a box with sides of AX, AY, and AZ meters long. Okay, so previously we already learned that the resultant force of A equals to AX plus AY plus AZ, right? But in Cartesian notation, you can represent it as AX I, AY J, and AZ you need to represent as K. Okay. So next is, if you wanted to find the magnitude, so it is similar. So magnitude is AX square plus AY square plus AZ square with a square root. Okay, it's like you are upgrading a little bit your 2D space Cartesian vector. Okay, but it is somehow a little bit different because this time it has 3 axes. Previously, it only has 2 axes. Okay, we have some interference. All right.
Sorry, doctor. My nephew.
Okay. All right, no problem. Okay, so as you can see here, if you have the resultant force A here, okay, you can, you have like an area here, okay. So an area here represented all of the elements. You have Z elements which directed towards, okay. You have the X element with directed towards you. So this is the X element, and the Y element which is directed on the right. Okay. So for this vector, you have all of the elements, X, Y, and Z. Right. So next is the direction of a Cartesian vector. So previously we already determined how we wanted to find the magnitude. But this time, what about the direction? Right. So the orientation or the direction of the vector A in 3D Cartesian is defined by the coordinate direction angles. So you have 3 coordinate direction angles. So previously you only have one, right? Theta. But this time you have 3. You have alpha, you have beta, and you have gamma. Okay. So these angles are measured between the vector and the positive of x, y, and z axis respectively. So when you are given some questions and they ask you to find the alpha, beta, and gamma for your 3D Cartesian vector representation, so you must know that it is only from the positive x, y, and z axis only. So it is not from the negative part unless it is specified. Okay, but if it is not specified, you must use from the positive x, y, and z axis. Okay, right. So in order for you to identify where is the positive, you need to use your right hand rule. Okay, so their range of values are varied from 0 to 180. So later on, when you get the answer, it must be from 0 to 180. But if it is greater than 180, it means that your answer is not correct. Okay? Right. Okay, so next you will have a unit vector. Unit vector is actually a unit which is used to simplify your equations. So after this, I will show you what is the unit vector. All right? So let us take a look at this figure. Okay, this is the alpha. Alpha is actually the angle which is from the x-axis. So you see, here is x-axis, and here is the resultant force. Okay, so the angle will comes from the positive x-axis. So positive x-axis will move towards here. Okay, here, right? So from this axis goes all the way towards the resultant force A. So this is alpha. Okay, so cos alpha equals to ax over a. So you need to use your trigonometric formula. Okay, so next is beta. Okay, so beta is all about the angle from the y-axis, the positive y-axis. So this is the positive y-axis which move from here to here. Okay, so this is the resultant force A. So the angle comes from the axis here. This one goes to the resultant force A here. So this is beta, right? Okay, next is gamma. So gamma is obviously for z-axis. Okay, so this is the resultant force here, A. So this is the z-axis. So it will come from this z-axis. The positive is here, from the origin point towards the upwards. All right. So it will comes from the axis of z-axis to the resultant force A. So from here, I'm sure that you can already differentiate. Okay, what are the differences between alpha, beta, and gamma, and where you can find those angle or those orientation. Okay, right. So you can also refer to here. Okay, this is your resultant force. Alpha comes from the x-axis. Goes here. Beta comes from the y-axis here. Okay, and gamma comes from the z-axis. From the z-axis towards the resultant force. Okay, right. So in addition to that, okay, if you wanted to find the angle alpha, beta, and gamma, you can use the cosine formula. Cos square alpha plus cos square beta plus cos square gamma equals to 1. Okay, so this is one of the important cosines formula in order for you to find the orientation of the angle for your 3D Cartesian representation. So you must know this formula. Okay, right. So A in Cartesian vector form. So right now we wanted to express the vector A, the resultant force A, in Cartesian vector form. So we have A here, A multiplied by UA. UA is here, the unit vector. Okay, UA. Unit vector is represented by A cos alpha, A cos beta plus A cos gamma, AX plus AY plus AZ. All right, so this is UA, the unit vector. All right, so in order for you to express, you need to go back to your triangle, right angle triangle later on. Previously that I already shown you. Sine equals to or opposite over hypotenuse, or and so on. Okay, so cos and tan. So you must verify those kind of things first before you come up with these equations. Okay, so you must be able to come up with this equation by what you call, by drawing separate triangle for your forces. Okay. All right. Next, Cartesian vector two angle. So previously we already learned that we can represent the direction of your Cartesian vector by using alpha, which is from the x-axis, beta, which is from the y-axis, and gamma, which is from the z-axis, z-axis. All right. But we can also represent the angle by using theta and also phi. Okay. So for theta, for example, okay, you have your resultant force A here, and then you can draw the simile, it's like the bayangan of A on the axis of x and y. Okay, this is A, and this is like the reflection of A, which is, we call it A prime. Okay, and then you get your theta here. Theta is from the AX. Okay, from the x-axis, you get your theta here. Okay, and then your phi is, as usual lah, your phi is actually represented from your z-axis. So z-axis directly to the resultant force, you will get your phi. Okay, so this is the component of A. You have AZ equals A, which is similar to A cos phi, A prime, which is A sine phi. So this is the angle of phi, and component of A prime. Okay, so because AX here, AX equals to A prime cos theta, so you can derive by using the trigonometric. Okay, and also AY equals to A prime sine theta. So this is AY. Okay, this is AY, and you can get A prime. This is A prime sine theta. This is theta. Okay, so when you substitute the A prime here with this one, you will get this equation. Okay, so if the question asks you to, okay, so right now you represent your Cartesian vector form by using only two angles, theta and also phi. So the equation that you will get is here. A sine phi cos theta I plus A sine phi sine theta j plus A cos phi k. Okay, but it is important for you to verify by observing your questions, the diagram of your questions. Okay, and you need to verify by drawing a separate triangle as usual. Okay, all right. So next is we will take a look for the example. So, but before that, do you have any questions on 3D Cartesian vector?
I think if we go through the example, it will be clearer, I think.
Okay, all right. So this is the example. Okay. So the example asks you to, let me stop the video. Okay. So this is the example. The example asks you to determine the magnitude and coordinate direction angles of the resultant force acting on the bracket. So this is the bracket. Okay. You can see here you have the z-axis, you have the y-axis, and you have the x-axis. So it means that this is 3D, okay, because you have three axes. All right, so the questions ask you to determine the magnitude and coordinate direction angle of the resultant force. So the resultant force is here, F1 equals to 450 Newton. I'm sorry, the resultant force, you need to find it, I'm sorry. But this time you have two forces. You have force 1 and we have force 2. So you need to sum it all together. Okay. So before we need to sum all of these vector all together, okay, you need to divide it into, you need to convert it into Cartesian, 3D Cartesian force first. Okay, so first we can convert the, I think let me, okay. So first we will solve for F1 first. So F1, we have F1 here. F1 is 2. So right now, can you tell me what is the angle? So is it easier for us to use 2, what do you call, 2 degree or 3 degree for this example?
2 degrees, sir.
2 degree. Okay. So if you want to use 2 degree, okay. So we will use the, what do we call, the formula for 2 degree, okay. So for F1 equals to, we have 450, okay, multiplied by cos 45 degree sine 30 degree. Okay, you can refer to the formula that I already shown to you. So 30, what is actually 30 degree? What it represent?
Theta, is it, sir? Theta or phi?
Theta.
Theta, okay.
30 degree is theta. And 45 degree is phi. Okay. So you can you can refer to the formula, okay. And then we have the direction of negative I, because it is actually the positive here. Okay, the first one is moved towards the back. Okay, so it is negative I, right? Plus, we have 450 here, cos 45, cos 30 degree. So what is the direction of J? Is it positive or negative?
Positive.
Yes. So positive J plus, next is we have 450 sine 45. So what is the direction of K? Positive or negative?
Positive as well, sir.
Okay, all right. So you have positive K. Okay. Okay, what about the second force, F2? What is the angle that we have here? Is it easier for us to use 2 angle or 3 angle? This is force number 2. Okay. What is the angle here? 60 represent what?
Beta.
Beta. So this is beta. 45 represent what?
Alpha.
Alpha. So we don't have what?
Gamma.
Gamma. Okay, so we don't have gamma. Right. So in order for us to find the gamma, so what is the gamma? It's like the something like gamma. Gamma. Okay, how we want to find gamma?
We use
So
the cosine formula.
yes, that's correct. So first we can find the gamma by using the cosine formula. So cos square alpha 2 plus cos square beta 2 plus cos square gamma 2 equals to 1. So when you solve this formula, or you solve these equations, so you can get the gamma 2 equals to 120 degree. Sorry. Okay, sorry for interruption. So I think I need to share the screen again. Okay. Right. Okay. So if you wanted to find the gamma, because we doesn't have any gamma here, so you need to use the cosine rules. Okay, cos square alpha 2 plus cos square beta 2. See, this is alpha 2, beta 2, because this is for cos number 2. Okay, and plus cos square gamma 2 equals to 1. Right, so eventually you will get gamma 2 equals to 120 degree after you're solving this formula, because you already have alpha 2 equals to 45, beta 2 equals to 60, and you just need to find the y2, just the gamma 2. Okay, right, so you will get the gamma 2 equals to 120 degree, so you can express cos 2 as 600 cos the alpha is 45 degree. So what is the direction for the I? I is positive or negative?
Positive.
Yes. Okay. Plus we have 600 cos 60 degree. What is the direction of J? Positive or negative?
Positive.
Positive. J. And next is, what is the direction of K? Plus 600 cos 120. What is the direction of K? Six hundred cos 120. What is the direction of K?
Negative K.
Okay. Right. So you will get the final answer, okay, of F1 equals to negative 159.10 plus 275.57 J plus 380.20 K. Okay, Newton. So this is your F1. So, okay, for your F2, right, you will get 424I plus 300J minus 300K. Newton. So this is the element of your force 1 and force 2 in Cartesian form, in 3D Cartesian form. Okay, so if you wanted to find the magnitude, okay, what you can do is you just simply Fr equals to F1 plus F2. Okay, so you add these two together first. You add by using each representation. I you must plus with I, J you must add with J, K you must add with K. Okay, so you will get 265.16I plus 575.57J plus 18.20K Newton. So you will get this answer. Okay. So this is your resultant force. It's like a summation. Okay. But your magnitude is, as usual, you need to Fr equals to, we have square root here. Okay. We have Fr of x in the square plus Fr y square plus fr z square. Okay. So you square all of this and you will get your fr. So it's like 633.97 Newton. Okay, so maybe you can round it into 634. All right. Okay. So for direction, so this is the magnitude. Okay. So for the direction, you can just simply using the formula of alpha, beta, and so gamma here. Okay. Alpha equals to cos inverse. You have frx over fr. Okay. You have equals to cos inverse. Sorry. Fry over fr. And the gamma is cos inverse frz over fr. Okay. So by using this formula, you can get the value of alpha, beta, and also gamma. Okay. So from here, your frx is here. So frx. This is your fry. And this is your frz. Okay. So you need to add all of the elements or all of the forces that you have all together. But you must add by using I. I you add with I, J you add with J, and K you add with K. And you will find the frx, fry, and frz. So to find the magnitude, you just use the square root frx square plus fry square plus frz square. Then you can get the answer. And if you wanted to find the direction, you can just use the formula of cosine inverse frx of fr, because all of this value you already get in the previous step of your calculation, right? But if you get the questions of 3D Cartesian vector, so first thing first, what you must do is that you must identify. Okay, you must identify from this video. Okay. So which if it doesn't mention what kind of degree, 2 degree or 3 degree system. So you need to verify which one is easier for me to use. Is it 2 degree or is it 3 degree? And you must know how you want to verify the angle. Alpha, beta, gamma, or theta, also phi. Okay, for 2 degree, we have theta and phi. Okay, is it this figure suitable for 2 degree? Or is it this figure is suitable for 3 degree? 3 degree is alpha, beta, and gamma. So you need to take a look at your questions, your degree, sorry, the forces system that is already given, and you must identify which one is more suitable. Okay. So do you understand this example? Guys?
Understand, sir.
Understand. So do you have any questions before?
Can you pass the slide?
Oh yeah, no problem. I will pass
Thank
the
you, sir.
slide and this video session
All right.
in
Thank you.
e-learning as usual. All right. Okay, so if you don't have any questions, I think that's all for today's class, right? So next week we will continue with the next lesson. Okay. The next lesson it is all about finding some directional and some of the elements which is still related to the forces. All right. So I hope that you will be able to understand the lesson that we have learned from last week and this week. Okay, but if you have any questions or any any inquiry, you can just ask me by using WhatsApp, or you can just ask in the WhatsApp group. Right? Okay, class. I think that's all for today's. Thank you for listening and thank you for your good cooperation. All right. Assalamualaikum and have a good day.
Thank you,
Waalaikumsalam.
Doctor.
Terima kasih,
Have a
Dokter.
good day.
Yes, sir.
Thank you, Doctor. Thank you, Doctor. Assalamualaikum, Doktor.
Waalaikumsalam.
Thank you, Doctor.
Welcome. All right, so next we will learn about 3D space Cartesian vector. So previously, we already learned about 2D space Cartesian vector, which we only have two elements, x and y axis. X is represented by the I element, and y axis is represented by the j element. So there is 2D Cartesian vector. But this time, we will learn about 3D space Cartesian vector. So what are the differences? So for 3D space Cartesian vector, we will use our right-handed coordinate system. So I'm sure that you already learned in your physics, right? So if you have, if you remember your right-handed coordinate system, so your thumbs point to the direction of the positive x-axis. So finger are curled about the z-axis and directed from the positive x toward y-axis. So you have your right angle here. Okay. So your thumb will direct it towards the positive z-axis, okay? And then you will have your y and x, okay? So when you you can also refer to this figure, okay? So the z-axis move upwards. The positive x-axis move towards you, okay? And the y-axis move towards your right, okay? So your thumb points upwards, your jari telunjuk points towards you, and the other part of your middle finger goes toward your right. So this is how the right-handed coordinate system works. All right. So this is one of the way that you can represent your 3D space. Okay, Cartesian vectors. Right. So for this 3D space, okay. So here we have A, which is the resultant force. Okay. So we have AZ here, AY here, and AX here. Okay. So A can be expressed as the combination of the X element, the Y element, and also the Z element. Okay. Right. Okay, so next, what is the Cartesian vector for 3D space? So first, you must consider a box with sides of AX, AY, and AZ meters long. Okay, so previously we already learned that the resultant force of A equals to AX plus AY plus AZ, right? But in Cartesian notation, you can represent it as AX, I, AY, J, and AZ, you need to represent as K. Okay. So next is, if you wanted to find the magnitude, so it is similar. So magnitude is AX square plus AY square plus AZ square with a square root. Okay, it's like you are upgrading a little bit your 2D space Cartesian vector. Okay, but it is somehow a little bit different because this time it has 3 axes. Previously, it only has 2 axes. Okay, we have some interference. All right.
Sorry, Doctor. My nephew.
Okay. All right, no problem. Okay, so as you can see here, if you have the resultant force A here, okay, you can, you have like an area here, okay. So an area here represented all of the elements. You have Z elements which directed towards, okay. You have the X element with directed towards you. So this is the X element, and the Y element which is directed on the right. Okay. So for this vector, you have all of the elements, X, Y, and Z. Right. So next is the direction of a Cartesian vector. So previously we already determined how we wanted to find the magnitude. But this time, what about the direction? Right. So the orientation or the direction of the vector A in 3D Cartesian is defined by the coordinate direction angles. So you have 3 coordinate direction angles. So previously you only have one, right? Theta. But this time you have 3. You have alpha, you have beta, and you have gamma. Okay. So these angles are measured between the vector and the positive of x, y, and z axis respectively. So when you are given some questions and they ask you to find the alpha, beta, and gamma for your 3D Cartesian vector representation, so you must know that it is only from the positive x, y, and z axis only. So it is not from the negative part unless it is specified. Okay, but if it is not specified, you must use from the positive x, y, and z axis. Okay, right. So in order for you to identify where is the positive, you need to use your right hand rule. Okay, so their range of values are varied from 0 to 180. So later on, when you get the answer, it must be from 0 to 180. But if it is greater than 180, it means that your answer is not correct. Okay? Right. Okay, so next you will have a unit vector. Unit vector is actually a unit which is used to simplify your equations. So after this, I will show you what is the unit vector. All right? So let us take a look at this figure. Okay, this is the alpha. Alpha is actually the angle which is from the x-axis. So you see, here is x-axis, and here is the resultant force. Okay, so the angle will comes from the positive x-axis. So positive x-axis will move towards here. Okay, here, right? So from this axis goes all the way towards the resultant force A. So this is alpha. Okay, so cos alpha equals to ax over a. So you need to use your trigonometric formula. Okay, so next is beta. Okay, so beta is all about the angle from the y-axis, the positive y-axis. So this is the positive y-axis which move from here to here. Okay, so this is the resultant force A. So the angle comes from the axis here. This one goes to the resultant force A here. So this is beta, right? Okay, next is gamma. So gamma is obviously for z-axis. Okay, so this is the resultant force here, A. So this is the z-axis. So it will comes from this z-axis. The positive is here, from the origin point towards the upwards. All right. So it will comes from the axis of z-axis to the resultant force A. So from here, I'm sure that you can already differentiate. Okay, what are the differences between alpha, beta, and gamma, and where you can find those angle or those orientation. Okay, right. So you can also refer to here. Okay, this is your resultant force. Alpha comes from the x-axis. Goes here. Beta comes from the y-axis here. Okay, and gamma comes from the z-axis. From the z-axis towards the resultant force. Okay, right. So in addition to that, okay, if you wanted to find the angle alpha, beta, and gamma, you can use the cosine formula. Cos square alpha plus cos square beta plus cos square gamma equals to 1. Okay, so this is one of the important cosines formula in order for you to find the orientation or the angle for your 3D Cartesian representation. So you must know this formula. Okay, right. So A in Cartesian vector form. So right now we wanted to express the vector A, the resultant force A, in Cartesian vector form. So we have A here, A multiplied by UA. UA is here, the unit vector. Okay, UA. Unit vector is represented by A cos alpha, A cos beta plus A cos gamma, AX plus AY plus AZ. All right, so this is UA, the unit vector. All right, so in order for you to express, you need to go back to your triangle, right angle triangle later on. Previously that I already shown you. Sine equals to or opposite over hypotenuse or and so on. Okay, so cos and tan. So you must verify those kind of things first before you come up with these equations. Okay, so you must be able to come up with this equation by what you call by drawing separate triangle for your forces. Okay. All right. Next, Cartesian vector two angle. So previously we already learned that we can represent the direction of your Cartesian vector by using alpha, which is from the x-axis, beta, which is from the y-axis, and gamma, which is from the z-axis, z-axis. All right. But we can also represent the angle by using theta and also phi. Okay. So for theta, for example, okay, you have your resultant force A here, and then you can draw the simile. It's like the bayangan of A on the axis of x and y. Okay, this is A, and this is like the reflection of A, which is we call it A prime. Okay, and then you get your theta here. Theta is from the AX. Okay, from the x-axis, you get your theta here. Okay, and then your phi is as usual lah. Your phi is actually represented from your z-axis. So z-axis directly to the resultant force, you will get your phi. Okay, so this is the component of A. You have AZ equals A, which is similar to A cos phi, A prime, which is A sine phi. So this is the angle of phi, and component of A prime. Okay, so because AX here, AX equals to A prime cos theta, so you can derive by using the trigonometric. Okay, and also AY equals to A prime sine theta. So this is AY. Okay, this is AY, and you can get A prime. This is A prime sine theta. This is theta. Okay, so when you substitute the A prime here with this one, you will get this equation. Okay, so if the question asks you to, okay, so right now you represent your Cartesian vector form by using only two angles, theta and also phi. So the equation that you will get is here. A sine phi cos theta I plus A sine phi sine theta j plus A cos phi k. Okay, but it is important for you to verify by observing your questions, the diagram of your questions. Okay, and you need to verify by drawing a separate triangle as usual. Okay, all right. So next is we will take a look for the example. So, but before that, do you have any questions on 3D Cartesian vector?
I think if we go through the example, it will be clearer, I think.
Okay, all right. So this is the example. Okay. So the example asks you to, let me stop the video. Okay. So this is the example. The example asks you to determine the magnitude and coordinate direction angles of the resultant force acting on the bracket. So this is the bracket. Okay. You can see here you have the z-axis, you have the y-axis, you have the x-axis. So it means that this is 3D, okay, because you have three axes. All right, so the questions ask you to determine the magnitude and coordinate direction angle of the resultant force. So the resultant force is here, F1 equals to 450 Newton. I'm sorry, the resultant force, you need to find it, I'm sorry. But this time you have two forces. You have force 1 and we have force 2. So you need to sum it all together. Okay. So before we need to sum all of these vector all together, okay, you need to divide it into you need to convert it into Cartesian 3D Cartesian force first. Okay, so first we can convert the I think let me okay. So first we will solve for F1 first. So F1, we have F1 here. F1 is 2. So right now, can you tell me what is the angle? So is it easier for us to use 2 or 3 degree for this example?
2 degrees, sir.
2 degree. Okay. So if you wanted to use 2 degree, okay. So we will use the what do we call the formula for 2 degree. Okay. So for F1 equals to we have 450. Okay, multiplied by cos 45 degree sine 30 degree. Okay, you can refer to the formula that I already shown to you. So 30, what is actually 30 degree? What it represent?
Theta, is it, sir? Theta or phi?
Theta.
Theta, okay.
30 degree is theta. And 45 degree is phi. Okay. So you can you can refer to the formula. Okay. And then we have the direction of negative I because it is actually the positive here. Okay. The first one is moved towards the back. Okay. So it is negative I. Right. Plus we have 450 here. Cos 45 cos 30 degree. So what is the direction of J? Is it positive or negative?
Positive.
Yes. So positive J plus next is we have 450 sine 45. So what is the direction of K? Positive or negative?
Positive as well, sir.
Okay. All right. So you have positive K. Okay. Okay, what about the second force, F2? What is the angle that we have here? Is it easier for us to use 2 angle or 3 angle? This is force number 2. Okay. What is the angle here? 60 represent what?
Beta.
Beta. Okay, this is beta. 45 represent what?
Alpha.
Alpha. So we don't have what?
Gamma.
Gamma. Okay, so we don't have gamma. Right. So in order for us to find the gamma, so what is the gamma? It's like the something like gamma. Gamma. Okay, how we want to find gamma?
We use
So-
the cosine formula.
Yes, that's correct. So first we can find the gamma by using the cosine formula. So cos square alpha 2 plus cos square beta 2 plus cos square gamma 2 equals to 1. So when you solve this formula or you solve these equations, so you can get the gamma 2 equals to 120 degree. Sorry. Okay, sorry for interruption. So I think I need to share the screen again. Okay. Right. Okay. So if you wanted to find the gamma, because we doesn't have any gamma here, so you need to use the cosine rules. Okay, cos square alpha 2 plus cos square beta 2. See, this is alpha 2, beta 2, because this is for cos number 2. Okay, and plus cos square gamma 2 equals to 1. Right, so eventually you will get gamma 2 equals to 120 degree after you're solving this formula, because you already have alpha 2 equals to 45, beta 2 equals to 60, and you just need to find the y2, just the gamma 2. Okay, right. So you will get the gamma 2 equals to 120 degree. So you can express cos 2 as 600 cos the alpha is 45 degree. So what is the direction for the I? I is positive or negative?
Positive.
Yes. Okay. Plus we have 600 cos 60 degree. What is the direction of J? Positive or negative?
Positive.
Positive. J. And next is, what is the direction of K? Plus 600 cos 120. What is the direction of K? Six hundred cos 120. What is the direction of K?
Negative K.
Okay. Right. So you will get the final answer, okay, of F1 equals to negative 159.10 plus 275.57 J plus 380.20 K. Okay, Newton. So this is your F1. So, okay, for your F2, right, you will get 424I plus 300J minus 300K. Newton. So this is the element of your force 1 and force 2 in Cartesian form, in 3D Cartesian form. Okay, so if you wanted to find the magnitude, okay, what you can do is you just simply Fr equals to F1 plus F2. Okay, so you add these two together first. You add by using each representation. I you must plus with I, J you must add with J, K you must add with K. Okay, so you will get 265.16I plus 575.57J plus 18.20K Newton. So you will get this answer. Okay. So this is your resultant force. It's like a summation. Okay. But your magnitude is, as usual, you need to Fr equals to, we have square root here. Okay. We have Fr of x in the square plus Fr y square plus FR Z square. Okay. So you square all of this and you will get your FR. So it's like 633.97 Newton. Okay, so maybe you can round it into 634. All right. Okay. So for direction, so this is the magnitude. Magnitude. Okay. So for the direction, you can just simply using the formula of alpha, beta, and so gamma here. Okay. Alpha equals to cos inverse. You have FRX over FR. Okay. You have equals to cos inverse. Sorry. FRY over FR. And the gamma is cos inverse FRZ over FR. Okay. So by using this formula, you can get the value of alpha, beta, and also gamma. Okay. So from here, your FRX is here. Your FRX. This is your FRY. And this is your FRZ. Okay. So you need to add all of the elements or all of the forces that you have all together. But you must add by using I. I you add with I, J you add with J, and K you add with K. And you will find the FRX, FRY, and FRZ. So to find the magnitude, you just use the square root FRX square plus FRY square plus FRZ square. Then you can get the answer. And if you wanted to find the direction, you can just use the formula of cosine inverse FRX of FR, because all of this value you already get in the previous step of your calculation, right? But if you get, the questions of 3D Cartesian vector, so first thing first, what you must do is that you must identify. Okay, you must identify from this video. Okay. So which if it doesn't mention what kind of degree, 2 degree or 3 degree system. So you need to verify which one is easier for me to use. Is it 2 degree or is it 3 degree? And you must know how you want to verify the angle. Alpha, beta, gamma, or theta, also phi. Okay, for 2 degree, we have theta and phi. Okay, is it this figure suitable for 2 degree? Or is it this figure is suitable for 3 degree? 3 degree is alpha, beta, and gamma. So you need to take a look at your questions, your degree, sorry, the forces system that is already given, and you must identify which one is more suitable. Okay. So do you understand this example? The dot product. Okay. Right. So let's take a look at this figure. This figure shows like a telecommunication tower which has been held by 3 different cables. Okay. So why points B, C, D are important? Are angles between the forces important? And how would you check these installations to make sure the angles were correct? Right, so from this figure, it is shown that the point BCD has been attached to the ground with the cable. So this is important because it is used to make sure that the tower will stay intact. Okay, right. The second one is, are the angles between the forces are important? Yes, it is important because based on that angle, you will define the position of the cable placement inside the ground. All right. So how will you check this installation to make sure the angles were correct? Okay, so how you wanted to ensure that the angle that you are using to make sure that the tower is intact on the ground is correct. So you need to use the dot product. Okay. So what is the function of dot product? Okay, so the dot product, it is used to determine. Okay, so the first one, why we are using the dot product is because first is we wanted to find the angle between two vectors. Okay, so let's say you have two vectors and then you wanted to find the angle between those two vectors. So to find that, you can use the dot product. Okay. Next is the dot product. It is used to find the projection of a vector in specified direction. Okay, so for the second application of dot product, so in case, for example, if you have one vector and you are given another projection of that particular vector, you can find it by using the dot product. So later on, I will show you some of the example of finding some angles between two vectors and finding the projection of a vector by using the dot product. Right. So the formula for the dot product is, so the dot product of vectors A and vector B is defined as A dot B equals to AB cos theta. Okay. So A and B here, A is a vector, B is a vector because we wanted to find between two vectors. Okay. So A is a vector and B is a vector. Whereas A here, this is a magnitude, A magnitude and B magnitude. Okay. Cos theta. Theta here is actually the angle between these two vectors, between vector A and vector B. Right. So this is actually the bold version of A. The bold A dot bold B equals to the normal A multiplied by the normal B multiplied by cos theta. Right. So this representation is here. Okay. So this is vector A and this is vector B, which is here, shown here. Okay. So A dot B equals to AB, the magnitude of the vector A, and the magnitude of the vector B multiplied by the cos theta. Theta is the angle between vector A and also vector B. Right. So the angle theta is the smallest angle between the two vectors and is always in a range of 0 to 180 degree. So you must take note that if you have two vectors, the theta is actually here. It is the smallest angle between the vectors. It is not from here, right? So this type of angle is actually large. So theta is always in range of 0 degree to 180 degree. So you must take note of that. Okay. All right. So in the dot product, we have some laws. Okay. So the law is just a simple law. Okay. So commutative law. So A dot B equals to B dot A. So it is similar. It doesn't matter. It's A dot B, B dot A. So those things are equal altogether. Okay. So next is the multiplication by a scalar. So if your dot product operation is multiplied by a scalar, for example, A here, the small a here. So the small a multiplied by the dot product of A and B, it will equals to the small a multiplied by the vector A dot B, okay, or A dot the small a multiplied by the vector B. So this is the multiplication by a scalar law. Okay, so you can multiply by a scalar of one of the vector, either it is A, either you want to multiply by A, or you want to multiply by B. Okay, and next is we have the distribution law. Right. So this the third law is if A has been dot with the operation, for example, B plus D, so it will equals to A dot B plus A dot D. Okay. So this is how the distribution law goes on in the dot product. Right. Okay. So for the dot product characteristics, so what are the characteristic of the dot product? Okay, so if you are if you are using the dot product in your solution later on, So the result of the dot product is a scalar. So it means that the result of your dot product is either in a positive or in a negative number. So the result is just in a number. Okay. So if your result after the dot product is like 5i plus 6j plus 8k, so it means that your operation or your answer is wrong. All right. So your answer must just in number. Okay. So your dot product result just must be in number. Right. So the units of the dot product will be the product of the units of the A and B vectors. So in order for you to define what is the unit of your dot product, so it is actually the same as the vector. So if your vector is a force vector, okay, so your unit is Newton. If your vector is in the position vector, so the unit for your dot product is meter. Okay, so you must know that the result of your dot product consists of a scalar, which is a number, and also a unit, which is depending on the vector itself. Right. So next is dot product of Cartesian unit vectors A and B. So if you are given the questions in Cartesian form, so how you wanted to initiate your dot product? Right. For example, the vector A here and the vector B here has been constructed in Cartesian unit. For example, you have AXI plus AYJ plus AZK dot BXI plus BYJ plus BZK. Okay, so how you wanted to operate the Cartesian unit dot product? Okay, so by applying dot product, you will be able to get this answer AXBX plus AYBY plus AZBZ. Okay, so how you wanted to do this? So you can do this by simply multiply, for example, here AXI dot BXI. Okay, and then AXI dot BXI equals to AXBX cos 0. You know, the 0 is actually because of I multiplied by I. Okay, so it is this in the same axis. So there are no angle between the vector. Okay, so it is 0. Okay, so next is if AXI multiplied by BYJ, so it means that I multiplied by J. So the theta will become 90 degree because the x-axis and the y-axis difference is 90 degree. So later on, when you expand these equations, okay, you will get this answer. Okay, and sometimes we ask these questions in the test or in the final exam. So how from this operation will become this? Okay, so you need to derive it by yourself, right? But you must remember that I multiplied by I, the theta is 0. I multiplied by J, the theta is 90. I multiplied by K also, the theta is 90. So you can use the equation here, AB cos theta, right? Cos the theta is depending on the I and J. I, J, and K, right? And then you will get this result. Okay? All right. Next, we will take a look at some of the applications for dot product. Okay? So the first application is the angle. All right, so the application of the dot product is actually the main function of the product itself. So we have two functions. The first function is to find the angle between vectors, and the second function is we wanted to find the projection of a vector. Okay, so let's take a look at the first application. Right, so the first application is the angle formed between two vectors of intersecting lines. So you see here we have the first vector here UA and the second vector here of UR. So this is the intersection line here, right? And this is the theta, which is the angle between the two vectors. You have vector UA and vector UR, right? So the angle theta between the rope, so this is the rope, and the beam, so this is the beam, can be determined by formulating unit vectors along the beam and rope, and then using the dot product. Okay, so unit vector you see here, UA and UR. This is the unit vectors. Right. So as I even mentioned before, okay, in order for us to find the angle between the two lines, we can use the dot product. So this is the general equations of the dot product. A dot B equals to AB cos theta. The vector A dot with the vector B equals to the magnitude of A multiplied by the magnitude of B cos theta. Okay, then we wanted to find the theta, so we need to rearrange the equations, and it will become theta equals to cos inverse the vector of A dot the vector of B over magnitude of A multiplied by magnitude of B. So you can find the theta. Right, similarly here, you see here we have the unit vector here. So unit vector is still a vector, okay? So you can use it to find the angle, right? So UA dot UR equals to, let's say the magnitude of A and magnitude of R is 1. 1 multiplied by 1 cos theta. So theta equals to cos inverse the unit vector of A multiplied by the unit vector of R. So this is the example of the application for the dot product. So if the questions wants you to find the angle between two vectors with the requirement that it has given for you the magnitude and also the, what do we call, the vector of the vector of the line itself, okay? It has given the magnitude and also the vector. All right, so you can find it by using the dot product. All right, so next application is the projection, okay? So recap. So the scalars, so we go to this one first, okay? Right, so let's say it has been given the vector of A, right? And then the questions ask you to find the projection of A here, the projection of vector A here along axis, this one, the small capital of A, along axis of A. So basically you need to find the vector of A, right? So this is a projection. So the projection means that you have a vector A here, okay? And then you project to the axis A here with the requirement that it will produce a right angle triangle. Okay, you can see here, it is producing right angle triangle. So right angle triangle, it means that you have 90 degree here. So this is right angle triangle. Okay, so this is the projection, right? And then if they wanted you to use to find the perpendicular projection of with respect to axis A here, you need to draw it here. So this is actually the projection also. This is actually also the projection of A, the vector A here. You project here, and it will produce 90 degree. Okay. So if the questions ask you, okay, find the projection, okay, subjected to the axis, okay, so you can use the dot product, right? Right. So basically, the dot product to unit vector. So these methods, the element inside the dot product is a little bit different compared to the previous applications. Okay. All right. So the previous application, it is actually the dot product of each vector, but this time, you have a vector A, and you dot with the unit vector, okay, of UA. Right. This is the unit vector. It is not the vector yet. Okay, this is only a unit vector. All right. So for you to define the unit vector, you need to go back to our previous lesson, which is related to the position vector. So in that lesson, I already show you how you wanted to find the unit vector, right? And I will also show it inside the example later on. Okay. Right. So let's say the unit vector UA equals to 1. Okay. You can just use A, this is magnitude of A multiplied by 1 cos theta, and you get A cos theta. All right. So A cos theta, so this dot product is also equals to the magnitude of vector AA. Okay. So this is AA, vector AA. So the magnitude of vector AA is equals to the vector of A multiplied by the vector of UA. Right. Right, so if you wanted to find the vector of AA, okay, this is quite confusing, you must multiply the magnitude with the unit vector, okay? Because basically, vector has two elements, okay? The first element is the magnitude, and the second element is the direction, okay? So if you have the magnitude of a vector, the vector is not completed yet, okay? And after you multiply it with the directions, so you will have the completed vector element, okay? So you must remember that, right? So the dot product of the vector A here, because right now we wanted to find the vector AA, the bold AA here. So the vector AA here, okay? We wanted to find it. So we must use the dot product. And after the product of the, after the operation of the dot product, you will multiply it again by the UA, okay? So you will get the vector of AA, right? Okay. So this one, okay, so if you already get, for example, it is given A, okay? And then the first questions ask you to find the AA, okay? So to find the vector along axis A, okay? And then you already find it. And then the third question, the second question asks you to find the perpendicular vector, which is this one, A perpendicular. So you can just draw it here because it is a parallel, and you can just use these equations, okay? So AA equals to A minus A perpendicular, or if you wanted to find A perpendicular equals to the vector A minus AA. So you can just simply subtract it, okay? So if you already find two elements of the projection, so you can find another simply by subtracting, all right? So this is just simple after you find the two elements of the projection. Right. So now let's take a look at the example, okay? So as usual, I will right. So can you see my example?
Yes, sir.
All right. Okay, so this is example 10, right? So example 10 shows that the frame shown is subjected to a horizontal force. See here, force, which is horizontal, is 300J. So it means that this horizontal force is the magnitude of the force, magnitude of the vector, okay? So determine the magnitude of the components of this force parallel and perpendicular to the member AB, right? So for this example 10, okay, it has been given here, the force equals to 300J Newton, okay? But the questions ask you to determine the magnitude, okay, of the components of this force parallel and perpendicular to the member AB, right? So you see this is A, okay, this is B, okay? So A and B, you must draw, this is the axis of AB, okay? Right? So this is the axis of AB, along AB, okay? So the questions ask you to find the magnitude of the components of this force parallel. So this is the parallel one. So this is FAB, okay? And perpendicular one, perpendicular is here. FAB, you have perpendicular line here, okay? So it is shown inside this figure, right? So this is the force that has been given, and they ask you to find the magnitude of the force parallel, which is here, and perpendicular, which is here, with respect to the axis AB here, okay? Right. So the magnitude of the component F along AB is equals to the dot product of F and the unit vector UB, which defines the direction of AB, right? So right now, we wanted to find the unit vector UB. Okay, we wanted to find the unit vector of B first. Okay, so this is already given. Okay, this question is already given the position. So we can use the position vector to find the unit vector. All right. So as according to our previous lesson, to find the unit vector, for example, unit vector of AB, equals to RB, which is the position vector. Okay, the bold one is the position vector, and the normal one is the length. Okay. We can differentiate. Okay. Right. So unit vector equals to the position vector over the length of the vector. Okay. So you can just simply observe by using here. Okay. So you have 2i plus 6j plus 3k. So you can observe here 2 in x-axis. Okay, and then you have 6 in y-axis, and you have 3 in z-axis. Okay, right? Because A is at the origin, so you don't have to, to complicate it because it is at 0, right? And then over, to calculate the length, we can just use the Pythagoras theorem. Okay, 2 square plus 6 square plus 3 square. Okay, so you will get the answer of 0.286i plus 0.857j plus 0.429k. Okay, so first you need to find the unit vector. Okay, and then you need to find the magnitude of the force AB here, this one, the one which is parallel. Okay, so first you wanted to find the magnitude first. Okay, so FAB equals to F cos theta, which is equals to the dot product of the cos vector of F dot UAB, okay, UAB here. Sorry. Okay. So you see here F dot UAB. Okay. So F here is the force here. Okay. F is the force here. Okay. All right. So it is already given 300J dot with UAB here, you already get here. Okay, 0.286i plus 0.857j plus 0.429k. Okay, and then what you should do is you should do the dot product. Right. So for the dot product, you need to multiply each element separately. Okay, but if you see here, it only has the element of j. So for the other element, it is considered as 0. Right? So you can just simply write 0 multiplied by 0.286 plus 300 multiplied by 0.857 plus 0 multiplied by 0.429. Right? And then you move the IJK, because the answer will become in scalar. It is not in vector. Okay, so after this you will get the answer of 257.1 Newton. Okay, so this is your answer, right? And then since the result is a positive scalar, okay, so because you get the result of your force AB here, so this is the magnitude. Okay, right? So if you get the what you call the force here, it means that the direction is parallel to the positive axis of AB. So it means that the direction is like this. right? It's not like this. Okay, it is not like this. It is towards the positive axis of x, y, z. All right, because it is positive here. And then next we need to find the vector of FAB, because it is easy for us to find the FAB. Later on, we wanted to find the perpendicular, right? So it is easier for us to find this. Okay, to find the perpendicular. So to find the perpendicular, we must find the vector of FAB first. Right now we already get the magnitude. Okay, next we wanted to find the vector. Okay, so to find the vector, so this is the bow of FAB. Okay, proportion equals to FAB, okay, multiplied by the unit vector of AB. So what you should do is this one, 257.1 multiplied with this one, 0.286i plus 0.857j plus 0.429k. Okay, so in order for you to find the vector of AB, okay, right, so you will get the answer of 73.5i plus 220j plus 110k. Okay, the unit is in Newton. Okay, and then you wanted to find the perpendicular component, right? So you can just simply F perpendicular equals to the force vector here. Okay, then minus with the force vector of AB. Okay, this is the bow one. Okay, bow one. Okay, right, and also this is the bow one. This is the vector. The bolt is vector. Okay, the not bolt is the magnitude. Okay, equals to F. You already got here 300j minus 73.5i plus 220j plus 110k. Okay, right, and then you will get the answer of negative 700. And this answer 73.5 I plus 79.6j minus 110k. Okay, so the unit is Newton, right? Okay, so the questions ask you to find the magnitude. Okay, right now you already get the magnitude of FAB, which is the parallel one. And then you already get the vector of the perpendicular one. And right now you wanted to find the magnitude only. So, as usual, you can just simply, by using this vector, you can use Pythagoras, or you can also, by using F, this one, F equals to F squared, this is F squared, minus FAB squared. So you can have either way. Okay, you will get 300 Newton squared minus 257.1 squared, and then you will get the answer of 155 Newton. So you have to weigh either you can find the magnitude from here, or you can just using the magnitude that you're already finding here. Okay, Pythagoras. First it is this. Now this is F. Okay, and then this is FAB. And this is the FAB perpendicular, right? So this is how you can find the force or the magnitude. If you are given one force, here. Okay, you are given one force here, force F. Okay, and they ask you to find the force of AB, which is parallel to this element here. Okay, and then at the same time, they also ask you to find the force perpendicular to the force AB, right? So if you are doing it in a normal way, so it will be quite confusing for you. So you can just use the dot product, right? So first, you must find the unit vector, okay, of the axis that has been specified. In this question, they want axis AB, right? So you find the unit vector of axis AB. Okay, to find the unit vector, it is actually the position vector over the length of the position vector. Get this answer. And then from this answer, you can find the magnitude of the force AB. Okay, force AB here by using the dot product. FAB equals to F cos theta equals to the vector of F here, okay, dot with the unit vector here, the unit vector of the axis that you wanted to find. And then you solve it, and then you will get this answer. This is 257.1. Okay, so this is the magnitude. Okay, so if you wanted to find, if the question asks you to find the vector, I don't want the magnitude, I want the vector. So if they wanted you to find the vector, you can just multiply it again with the unit vector here. Okay, so unit vector here is it plays a very important role. So you must know how to find the unit vector of an axis. Okay, so you must multiply again by the unit vector, and this is your vector. Okay, so this is your vector of FAB. And then they ask you to find the one which is the perpendicular one. So you already got your F and you already got your FAB. So you can just minus it together. So this is actually the vector of F perpendicular, right? And if you wanted to find the magnitude, you can also use from here, you can use the formula, or you can just use the Pythagoras from here. Okay, because FAB you already have, F you already have. So F square minus FAB square root equals to this one. Okay, because Pythagoras simple, F equals to FAB square plus FAB parallel square root. So this is Pythagoras theorem. Okay, so for F. All right. So if you want to find FAB, so you can just do the same thing. Okay. All right. Next, can you understand this example? Or you want me to repeat some parts? Guys? Can you hear me?
Can sir, can, but tengah brain.
Okay, tengah brain because this subject is becoming more difficult. Bila kita masuk ke dalam lagi more chapter, but yeah. Okay, next I will show you another example. Yeah, this example is quite hard, but yeah, I think it is manageable. Okay, right. For the second example, okay, the example asks you the pipe is subjected to the force of F. Okay, so this is the pipe, and then you have the force F equals to 80 Newton. So actually, all of the unit here is in meter and in Newton. Meter, and meter. Okay, right. So the pipe is subjected to a force of F equals to 80 Newton. So you have the force here. Okay. So this time, this question asks you to determine the angle theta here, okay, between F and the pipe segment of BA, right? So you can see here that you already get your axis, okay? Your axis is BA, okay? And your force is here, under the segment of DC, okay? And the question asks you to determine the angle of theta and also the projection F along this segment. So it means that the projection F means that the vector. Okay. Right. So first, we need to find the position vector from B to A and B to C. Okay. So basically what you have learned and what I believe that you already understand last class is how you wanted to find the force vector, right? Because it is already given the sum of the position here. So you can find the force vector easily. Okay. So the force vector, for example, of RBA, okay, first you need to find the force vector in order for you to find the unit vector. Yeah, something like that. Right. So force vector of RBA equals to negative 2I minus 2J plus 1K. Okay. So this is the unit vector of B to A. Okay. And then you have unit vector of R B to C. Okay. B to C here. Okay. So you will get negative 3J plus 1K. Okay. And then you will get the length, okay, of RBA equals to 3 meter and RBC equals to square root 10 meter. So I wanted to ask you, how you want to find the length of RBA? Guys? How you wanted to find the length of RBA? It is given the position vector here. How you wanted to find this? Do you remember? Guys, do you remember how to do it? Hello?
I don't think we remember.
Negative 2 over 3 maybe. Negative 2 over 3 and 1 over 3. RBA over RBA.
Oh yes, that is the data. But how you want to find the length? Here.
Oh,
This is the position vector. This is the length.
not sure.
Sure. Or you can just use this one. Ini, okay, 2 square plus 2 square plus 1 square. So dapatlah 3. Just like that. Sama juga dengan yang ni. 3 ni square root 3 tambah square root 1. Macam ni juga. Ni dapatlah square root 10. Simple je. Okay. So you must remember how to do it. Okay. Alright, next is cos theta. Theta equals to this one, RBA dot RBC over RBA RBC. Okay, this is the okay. And then you will get the answer of 0.7379. Okay, so you will get the theta equals to 42.5 degree here. Okay, so this is the way that you wanted to find the theta, which is the angle between the two vectors. Okay, by using the equation of RBA, by using the equation of the vector of the bottom one is the vector of RBA dot vector of RBC. This is RBA, the first vector. Okay, this is RBC, the second vector, we want to find the data. So you can use the dot product, which is one of the application of the dot product. Okay. So RBA dot RBC equals to the magnitude of BA, which is the length, multiplied by the magnitude of BC, which is the length that we find earlier by using this equation. Okay. You get first, you need to get the position vector. Okay. And then you can get the length by just square each element here. 2 squared plus 2 squared plus 1 squared square root, and then you get the length, which is the magnitude here. Okay. So according to the dot product RBA, okay, the vector of RBA dot the vector of RBC equals to magnitude of RBA multiplied by the magnitude of RBC cos theta. So from here, you will get this equation. Okay. And then you just substitute the value, and then you get the answer here. Right? Okay. And then the component next, we wanted to find the projection of F along the segment of AB. Okay. So what you need to do is you need to find the unit vector. Okay, unit vector U here. So already have here RBA. Okay, unit vector of BA equals to the cos vector of RBA over the, this is the position vector here, over the length, which is the RBA, the number of RBA. Okay, it will be equals to negative 2 over 3, because negative 2 over 3 here, I minus 2 over 3, 2 over 3j plus 1 over 3k. Okay, so this is the unit vector you already get, right? And then the force vector that you get, okay, the F along AB. So F, sorry, the F equals to force vector AB is, you have here 80 Newton here. It is not the pound, it's Newton. So 80 multiplied by the unit vector here, UBA. So you will get, I'm sorry, for this one, okay, it's not UBA. Right, so this is the magnitude, okay, F 80 Newton. Okay, if you wanted to use the dot product, you need to convert this magnitude into the force vector. Okay, so you already get the magnitude of 80 Newton here. So 80 Newton. Okay, and then you need to multiply with the axis that it has. Okay, so 80 Newton multiplied by the unit vector of this one. The axis that it has is BC. This force is moved along axis BC. Okay, so it means that you must multiply by the unit vector of BC. Okay, so it is similar to find here UBA, position vector over the length, similar to UBC. UBC equals to position vector of BC divided by the length of BC. Okay, so 80 multiplied by negative 3 over square root 10j plus, okay, this one negative 3 over 10j plus 80 multiplied by negative 3 over square root 10j plus with 1 over square root 10. Okay, so you can get the answer here of the cos. Okay, cos here. in the force here. And then they ask you to find the force of BA. Okay, so FBA, magnitude of FBA goes to the dot product F dot U BA equals to, you already get here, negative 75 89J, this here, okay, plus 25.30K. So you get it here, okay. Dot with negative 2 over 3I, this one, okay, minus 2 over 3J plus 1 over 3K. Okay, and then you will get the answer of 59.0 Newton. Okay, right. Okay, so you can get this example. All right. So right now, I'm sure that you don't understand. So I will explain it to you a little bit simpler. Okay. All right. Can you hear me?
Yes, sir.
Can sir. Sir, can I ask a question before you start?
Yeah.
Just now the RBA, right? It was negative 2I, negative 2J plus 1K. Why was it like that?
Oh, okay. This one.
Yeah. Why the negative and why the positive is like inverted?
Okay. So this is all about the position vector. This one.
Okay.
Okay. So because it is B to A, we need to find the position of B first, right? A minus B.
Okay. So it's from B to A, so it's upwards. So that's
So,
why it's 1K, right?
Yeah.
Okay. So what about the I? It goes.
Like let me check it. Okay, so actually this is B to A. Okay, so it means that A must be minus by B, right?
Yes.
Okay.
Uh-huh.
So right now the position of A is, what is the position of A?
It's
Zero.
2J.
Okay. A is
2J, right?
yeah, 2J. A equals to J. B equals to
So,
B
it's,
equals
so I
to,
think A is just 1J. Just J.
oh, okay, just
Because
J.
1 meter.
1J. B 1J. B equals to 2I 2I.
Minus K.
It doesn't have
Uh,
J.
plus 1 juga kan?
2I 3. This is J, right? This is
Uh-huh.
1. This is 2.
Oh, dia sampai sana. Oh, okay.
Plus 3J plus how many K?
1K
1K.
lah.
1K. So
Plus
because
ke minus lah?
minus, sorry. Minus 1K. Okay. So because the segment is given as BA, so B to A. Okay. So in order for us to find the position vector, A must be minus by B. So A tolak B. A minus B equals to 0 minus 2, right?
2.
0 minus 2 equals to
Negative 2 silap.
0 minus 1 minus 3 equals to
Negative 2.
negative 2. Negative 2J. Okay. And then 0 minus negative 1 equals to?
Positive 1.
Yes, plus K. So this is how. Ya, yang kita kena tengok elok-elok sikit tu. Kalau
I
salah
see.
tu,
Thank you, sir.
kalau salah tu bye-bye lah. Alright. Okay. So I think I need to explain a little bit simpler here. Yeah. let's see. Put it here. Let's see here. You have one force here. Okay. And then the questions ask you to find the force along this axis. Okay. This axis, for example, axis X. Okay. All right. So, and it also wants you to find the perpendicular force, which is perpendicular to axis X. So we call it axis X perpendicular. Okay. So to find the what do you call, to find the force? Okay. So first, okay, because it is dot product, so it must be right angle. Okay. Right. And then first thing first, you must find the unit vector. Okay. The unit vector, which is represented by unit vector of X. Okay. First, you need to find the unit vector of X. So to find it, equals to position vector, okay, over length of position vector. Okay, so this is the position vector over length of the position vector. So this is how you want it to find. This is the unit vector of X. Okay, so you must go back on how you want to find the position vector, and you divide it by the length of the position vector. Okay, and then if the force is given, it is already given in the force mass equals to, this is the must be force vector, which is in I, J, and K. Okay, must be in force vector, right? If it is not in force vector, you must do it in force vector anyway. Okay, if it give in magnitude, you must find in force vector in order for you to get the answer. Okay, and then from that, okay, if they ask you to find the theta, okay, theta equals to, okay, so next we need to find the fx. Okay, so fx equals to, okay, so this is both one. Fx equals to force vector of x, and then fx not both is equals to magnitude of force x. So this is the difference. The bold one is the force vector, and the not bold one is the magnitude. Okay, and then, right, if we get the dot product, okay, the dot product is used to find the magnitude, right, with the force vector is known. Okay, so if you wanted to find the force vector, okay, it is simply f x equals to magnitude of force x multiplied by ux. Okay, the magnitude of force x equals to here, fx here. So to find the fx, okay, fx equals to, okay, let me see. So to find the fx, okay, how to find it? Find the fx, we need to use fx equals to, this is f here, okay, you must boleh lah sebab dia unit vector. Okay, the bold f, okay, dot product with ux. Okay, So you can find by using this formula. Right? So dia ibarat rotate-rotate macam tu je lah. Okay? And then the second, if the another question asks you to find the theta. How to find the theta? Okay? So to find the theta, you can use it is depending on the question. So if the question's given the vector here and the vector here, you can find it similar. You can find it easily. Okay. So to find the vector here, it is just simply by using f here dot this one fx to fx cos theta. Okay, so you move it, theta equals to cos inverse f o the f o x over f at x. Okay, so this is how you can find it, right? Okay, so if there is sebenarnya kalau if the question given the force here and they ask you to find the projection, you can use this one. But if the question is a little bit different, so you need to use another method lah, right? Okay, so I think you need some time to understand it, and yeah, you can watch it again and process it again. Okay, so this is number 1. This is number 2. Okay, this is number 3. This is number 4. This is all of the things that you need to know in dot product. Okay, in order for you to solve the questions later on. Right. So we will take a 5 minutes break. Okay, before we proceed with chapter 3. Chapter 3 is really simple. It is just the equilibrium. Okay. Tapi dia lagi simple daripada yang ni. Alright.